Good morning, everyone, and welcome to my talk. My name is Mehmet Akif Tütüncü, and I will talk about errors today and my little project called E. I'm a software engineer from Istanbul, Turkey, and I started learning Scala around 2014, and I've been writing Scala ever since. I currently work at sahibinden.com. It's one of the biggest websites in Turkey. It's a Craigslist-like posting website. I mainly work on JVM with Scala and now with Java and Kotlin as well. I love open source. Almost everything I do is open source, and I try to contribute as much. And I'm really excited about this talk because this is my first conference talk, and I'd like to thank to ScalaUA for this opportunity. You can find me online with M. Akif Tütüncü username. I use the same username everywhere. And let's begin. This talk will be about my experiences in dealing with errors through these years. I applied different approaches. I've seen different styles, and I gathered some of those. And I split these into 5 main topics. First, I'd like to talk about exceptions versus errors and how they differ. And in my project, this is a spoiler alert, I prefer errors over exceptions. Then the next step is how to define an error, getting to know the errors. So modeling an error object. I call this E in my project. It's the name of the error model and the project. And the next step is how to live with this error. When we have an error, how to deal with this, how to carry it around and stuff. And the next step would be, I call this admitting to having errors, because we have an error, we modeled it, we communicated about it in our code, but what about the outside world? When we have an error, how do we represent this? And as a last step, I will talk about how I chose to unify this on the JVM for not only Scala, but Java and Kotlin as well, and possibly can be implemented for others as well. And let's start. The first topic, as I said, is exceptions versus errors. So let's compare them by starting with exceptions. Exceptions are one way on JVM that can represent errors. As the name implies, they are for exceptional situations in our programs. So getting an exception can mean something did not go as expected, and it's not possible for us to produce a result and continue our program execution as we expected. So they are necessary, but they have certain disadvantages when they are used for the non-exceptional sort of expected error cases. The first one is they are not referentially transparent. What I mean by this is, what referential transparency is, when you call a function referentially transparent, you should be able to replace the call to that function, take the call out, and put the result back in, and you'll have the same program as before. if a function can do this, if we can do this with a function, we can call this a referentially transparent function. So exceptions break this because you when you have a function, when you have some code that throws an exception, you cannot for sure treat it as a value of that certain type. I'll show an example of this in a minute. Another advantage can be that they are difficult to reason about. When you look at the code, you might not directly understand that it can fail. It throws an exception. It's not the type, it's not the result that we see written in the code. And they can be costly. With exceptions, the program flow is broken. The stack trace is built, it's carried around, the context is changed, etc. These all come at a performance cost and some memory cost as well. And exceptions prevent us from writing type-safe code. It is related to the runtime, and therefore, because they are not just values and they are meant to break the program, it's not easy or even possible to find them during the compile time. It's much easier to miss an error if it is an exception, and the consequences can be huge because things could be failing on production just because we cannot see it during compile time. So let's see an example of this. Here's a piece of Scala code. It's a simple looking for something on a database scenario. As database, I just put a map there. So in this find method, I'd like to focus on these parts. So the find method indicates that it returns a person, and in the case that it cannot find a person with such an ID, it throws an exception saying not found, and in the use of find method below, where we want to print the name of the person we found, we call the find, and since the type says it's a person, we use the name field of it. But this is the case where the referential transparency is broken. Find method defines that it is a person because it returns a person. But if we were to replace the find call with its result, the program is not the same if the person is not found, if an exception is thrown. So this is a non-exceptional case, actually, because for a find method, for a find function, it is entirely expected that the requested person cannot be found. So in the case we use an exception, we lose this ability of referential transparency. And sure, we can return null or option to indicate that person does not exist, and it would work in this case, but from a general point of view, we won't have a way to indicate the error, what the error is, and or we have more than one way to do this. So let's see another example of this with when we get rid of errors, when we get rid of exceptions. How do we do this? By using some ordinary values as errors, and let's talk about these ordinary values as errors. So if we move away from exceptions and use some error data as ordinary value, we can have the ability of referential transparency again, and we would not pay the cost of the exceptions that I talked about. Things would be easier to reason about in the code because to be able to use the value error as a value, we would have to well code it. So when we look at the code, we would see that things would return an error and or a value that we wanted. So things are type safe and related to compile time compared to how it is in runtime when we use the exceptions. So I'm going to show the same code, but without the exceptions. If you are familiar with Scala, you'll know the either type, and let's focus on the same parts again. This time, return type is not just a person, but instead it is either a string, which in this case represents our errors, or a person. And I removed the exception and replaced it with a left instance saying a person is not found. And in the find method call, because the return type is not simply a person anymore, we have to deal with this error. We have to use the either type in a way to deal with the error so that things are in compile time right now. When we look at this code, we understand that when we call find, because things can fail, we have to use the for each or some other way to handle the error and access the value when it is present. So when we do this, we can simply replace the find call with the result, and the program would still be the same. And this brings us back to referential transparency. So yeah, we can represent errors as just values. In this case, it was a string, but it might not be enough for all the cases. In fact, it isn't. And we can argue that the left type of the either can be exception or throwable so that we can cover many cases, but it would still be using the exceptions. An exception would still need to be created and caught possibly. And it doesn't really remove all the disadvantages of using exceptions as the errors. So what can we do about this? Let's model our own error object so we can represent any error we want. So that's how I started my journey. I first designed a class, an error model, which simply just held error-related data. So it was just a dumb class. It can hold some values, and it is an ordinary value that I can use with errors. So because we said errors are values and we want to use one type, I wanted to use one type, I came up with this. I made small changes over time to these fields, but this is the final form I decided on. So I said that an error can have a code, a numerical number, a name. It's more like a machine-readable enumeration-like name, a message which would be human-readable, telling us what happened, and a cause, and which is another object, and this object can be an exception depending on what platform we are, that caused this error to occur, and some arbitrary data, which is a map of string to string, that can be related to this error, that can help us understand why the error occurred. So I built this, I wrote this class and called it E because I like short and simple names. E stands for error. And I quickly realized that I need a good API, good, friendly, and immutable API for this E class, because this would be the most important part of my error handling, and it should be really easy to create an E instance, an E object, and modify some existing ones. So let's see some examples of that. Here you can see creating an empty error, or just an error with some name and message, or reusing some error object and modifying it to add a cause, exception, and some related data. As you can see, we have an arithmetic error E object, and the related data, it could be the input, so that we can understand why that error can happen. And in this E3 value, I show the complete object creation. Things are optional here. Not all errors are the same. Not all errors have to have all these fields. So you can mix and match depending on your requirements. And these are immutable, as I said. Any modification returns a new instance, just like calling the data method to attach some related data to the error. So now that we have an error model E, we can let's see how we can use it in our programs. So we have the either, which can work when we say the error type is E, but I found that it might not always be enough. The API, the methods it has might not always be enough. Plus, because I want to keep the error type fixed as E, there is no actual need to write either and keep typing E as the left type. So I wanted to simplify the type signature as well. I just want to call it something. I decided to call it maybe. And when I say maybe of A, it means that there can be a value of A, or there can be a failure with a type of E. So in this sense, it is similar to either E and A, plus some semantics of try in Scala. So this is how I represented the container object that I called maybe. One other reason I decided to do this and not just use either is that I wanted this E project to be available across JVM, not just for Scala. That's why I implemented one of my own types here. So it has two subtypes, two possible values. It can either be a failure with which can contain an E, or it can be a success which can hold our value of type A. So there are many methods you can construct and work with this maybe type. The to maybe converts things, values or E's to maybe. From can construct a maybe from various types. Catching is another method. It helps with the exceptions part of error handling. That's how I said it's similar to try. And there are handle error methods, which all will look really familiar if you are familiar with Scala. So let's see some example code. This is a simplified definition of how a maybe is defined. So there is a maybe type with the type parameter a, and it can either be a failure holding an e, or it can be a value. It can be a success holding a value of a. So very simple building of maybe could be these maybe success or maybe failure methods, or with required imports and syntax extensions. You can directly call toMaybe on objects on any type you want, and it can be converted to a maybe instance. Here are some examples of from option, either and try methods. These are methods that help you convert from that related type to a maybe, as long as you can provide the error case yourself. So for an option, the error case is that option is none. The value is not there. So if you give me an E for that case, I can make a maybe for you. Either and try are the same. You just convert the left value to an E, or the exception in the try to an E, and you get yourself a maybe. This is another example, and this one uses catch and handle error methods of maybe. So there's an unsafe method that we understand it can throw exception. So if we wrap this method call to maybe catching and handle the exception case by converting it to an E, we can construct a maybe, and handle error cases are similar to the try API in Scala. I'm just passing these because there are many more examples on the repository, and not to take too much time. So now we have an error model, a maybe model that can represent values that can potentially fail with our custom type. So we can use these in our code base. So we can return maybe from some methods, we can handle, we can convert values. That's all fine, but what do we do next? So at a certain point, when we see that we have the error, we would probably need to communicate about it, saying that we have an error in our code. So naturally, things come to this point where we want to encode our error or the maybe type, so we can convert it to another type and give it to someone else. And there may be cases where we want to, where we would be on the other side of this, so that we receive a value, we know it is either a value or an error. So we may want to decode it into our types. So I introduced encoder and decoder, and codec, which is just a combination of these two. So let's consider a microservice example where we have a JSON API, and when there's an error, we would also need to convert that error to a JSON, so that we can tell the client, whoever called us, whoever requested something, that we have an error and here's a JSON representation of it. So it would be cool if we can just convert an E to a JSON, because our E contains the related data to our error, and it has a fixed format. So there is a built-in class called JSON string encoder, which simply builds a JSON formatted string from an E object. In fact, it is the default two-string implementation of E, so you probably don't even have to do much, depending on what JSON library, how you use, how you convert things to JSON. But it is there. And there are also separate modules for Google's Json or Cersei or PlayJSON JSON libraries. They provide their own custom converter types so that you can convert an E or maybe to a JSON. Or you can even build your custom encoders using the encoder type that comes with E. So let's see an example of that. As you can see, we have a simple error here. The toString method just converts it to a regular string in a JSON format. Or I wrote a simple CSV encoder here. It just uses name, message, and code fields of an error, and just separates them with commas. So it looks like a CSV formatted string. And encoder is just a simple interface with a single method. So you can even write new abstract instances like this. It's basically a function from E to whatever type you want, and you get that encoders. You get that type's encoder. And since we can encode things, we might want to decode things. Decoding, well, for example, a service could want to understand the error it receives, maybe modify it and send it to another service, or just log it, save it, whatever. So we may want to decode things, and decoding is slightly more complicated than encoding, because the input can, the encoded value can also be invalid. So decoding operation itself can fail. So I introduced the decoding result type, and it either gives you the decoded E object or the failure represented again by an E object. So when you decode things, you get an E, but that E could be the decoded value or the decoding failure. And here's an example of that CSV encoder counterpart, decoder, CSV decoder. It just splits with the commas, takes 3 values, converts them to the correct type, and constructs an E. Or it says it fails, and it says why it failed with an E. Again, there are third-party modules already included in the project. And one last thing I want to talk about is unifying the error handling. As I said, I wanted this project to be available for not just Scala, but other JVM languages as well. So I went with Java and Kotlin. I implemented them myself, but it can, in theory, be extended to other languages as well. And the primary goal of this project E is to unify the error handling in a way that it is across languages, apps, or code bases. You can use the same approaches, same types, same classes, and you have a consistent way of error handling. It is intended to be extendable, and I already provide some commonly used modules for integrations with like JSON libraries for encoding and decoding. I have a Zio module as well. Just if you are familiar with Zio, Zio has a dedicated channel for for errors. So the Zio module provides you with a type alias that just fixes the error channel to my E, so that you don't have to deal with different types of errors. You can represent all the types with just an E type. It provides some extra methods to convert things, etc. And uh, and I'd like to summarize what I talked about. So how I uh, how I wanted to achieve this unity of error handling is just representing errors with one type, one good enough type that I can represent any error. I called it E, and I needed to manage things that can fail across different languages. So I couldn't just use Scala's either. So I introduced maybe, and anything that can fail, I would represent with maybe type. Then I would communicate about these errors with encoders and decoders, and I extended the implementation for different needs using different modules. And E, as I said, is an open source project, so feel free to contribute. Any kind of contribution is welcome. You can provide your own implementations for stuff, an integration for another module, etc. Or things that you utilize, things that you use E in it. You can contribute and say, hey, I use E here, we can do this with E, etc. And that's pretty much it. I know it's early, but it went kind of quick. I have more examples and ex some example projects and much more documentation on GitHub. I could show you those, or if you have any questions, I can answer. I can show a few things since I still have time, some extra documentation and example projects on GitHub. So this is the project page here, and I'll just go to examples and use cases page. I have 4 example projects here. I wanted to mix and match stuff. I wrote a Spring Boot project in Java that uses E. I wrote a Play Framework project written in Scala that uses Zio. I have an HTTP4S project, again written in Scala, that uses Cersei encoders, and a Ktor project that uses Kotlin. It's written in Kotlin. So there are some use cases I mentioned here. The first one is the eliminating need for exception. Here's another example, a bit more involved example than the one in slides. Here's a regular Java code that's throwing exceptions, and here is how it would look. It returned a maybe and did not throw any exceptions. This is another use case I personally use. Because E has a code field that is a numeric value, I tend to use this in microservice, and anything that communicates over HTTP. I wanted a way to map an error to an HTTP status code so that I can simply just use errors and not care about how it would go out as HTTP responses. So I decided to use the code field in the E as an HTTP status. And here I build an E with a code 400. So when my code fails with this E, it will just go out as bad request. And for successful values, I use 200. When doing this, it's important to not repeat yourself. So I can curate some base error types and reuse them, just modify them with different needs. What I do with this in HTTP case is that I just define a bad request E, which only has the code and maybe the name field. Then I modify it whenever I want an error that should result in a bad request type of scenario. I provide more meaningful messages and related data, but it's still that 400 error E, so it goes out as 400. Or it can be used for validating input as well, user input. This is an example in Kotlin. I write various validators that can return a maybe, and I can just simply chain them right here. That's all from me. Thank you very much for listening. If you have any questions or you want to talk about some stuff, feel free to reach me. The first one was from Geoffrey. These are in my Slack channel. What he proposed was maybe rethinking the name maybe, the container type that I implemented, I called maybe. He pointed out that maybe is a type in Haskell and it means something else. It's like an optional type in Haskell. And there was a discussion about that. I thought about some different names before I came up with the maybe name. I thought about calling things, calling it something like result or response, because they would also work. But I found that the maybe name is more general, and result or response tend to, it tends to mean that we are in the HTTP web domain, and I didn't want this E project to be specific to that. It can be used for that domain, yes, but I didn't want it to be specific to that domain. So I wanted a more general name. That's why I went with the name maybe. And there was also a joke about this, that I could name it hopefully. So when we return something, we would read it as, this is hopefully an A. And yeah, that's about this for that question. There was another one. I hope I'm reading the name correctly. Vladimir, I'm not sure.
Vladimir, right.
Yeah. He pointed out that they had something similar and they called it response. They also held the HTTP error code inside that class. but he pointed out that there could be some drawbacks to using this, where they would need to check everything before they used it for the errors, and they would need things like map or rethrow or else methods to help with these error checks. I specifically designed E and maybe this way because I wanted the code I write using E and maybe to force me to check for errors anytime I want to use something. So in this way, on a design level, this is something similar to other languages might use. He pointed out that Rust has some built-in support for error handling, and I said Go also has something similar. And as far as I know, that Go has errors, not exceptions, and when something returns, it can always have an error value that you need to check before you use that value. So although I didn't really think about this while writing E, the design principles are the same. Basically, what I wanted was when you use E and maybe in your code, you call something, you get a maybe, and the compiler of the types forces you to check that thing for a potential error before you continue. And in many cases, especially if you are writing Scala and functional code, you, instead of checking it every time, everywhere, you tend to convert things from one thing to another, and you call something, then you map over it, you pass it to somewhere else, and you tend to carry that error around, and at the edge you check if there's an error, respond somewhere, some way, and if there's a value, respond some way. And this made me realize that I needed encoding and decoding in this part of my project, so that I implemented that as well in my code.
Sorry, may I ask a question?
Sure.
So you use maybe as input parameters to some methods, also as input parameters, or?
I haven't, but nothing is stopping you from using that. At least, as I said, at the edge of your program, when you carry something around, which is a maybe, and at the edge you want to check, you would probably write a method or a function that will take it as an input parameter. So technically there's nothing wrong with that, but it's your choice, I guess.
I understand, yeah. From compiler point of view, nothing wrong with that. But
sorry?
I mean, from compiler point of view, nothing wrong with it, I understand. But for me, I think that like if you have some business logic method, not just some method to unwrap maybe, but some business logic method to pass there maybe.
The business logic.
It feels wrong. It's
so
like
the business logic where you would require a maybe as an input could be maybe validators, data validators. In one of the example projects in the repository, I have validators dealing with maybe. I think it was in the Kotlin example. Let me see if I can find it so I can share my screen and show. Let's go there.
Can I meanwhile ask another question?
Of course.
Did you wrap like any method response into maybe like any method with not any all method responses? I mean, if you have some methods that just like parse some data, like parse data, not parse data, it could be actually could be error with parsing, but really we often have methods that like not couldn't produce response, but it's very I mean, so yeah, I hope you understand. So my question is, are you wrapping really all method responses into maybe?
No, not really. I wrap only the things that are potentially can potentially fail with maybe.
Okay.
So that, well, from my point of view, the types, the return types, and the types of values always tell the truth. So because I want to trust the types, I only return maybes or wrap things in maybe when I know things can fail. If I have a pure data, if I have some method that will just concatenate some string and build things, I wouldn't return it as a maybe. But if I have another method that will call that string concatenation method, and some other method that will actually that can actually fail with a maybe. So let's call the string method make string and the other one get something from DB. If I have another method that uses these both methods, the make string method would return a string, get something method would return a maybe, and the method I am writing that uses both of them would also return maybe, because there is something that can potentially fail down the road in that method.
I understand.
I don't wrap everything.
Actually, interesting questions. In our project, it's like it was my question about response. Like as I say, we call this class response because we are mostly working with web, but doesn't matter. So we wrap into maybe all HTTP calls to third-party services, because like HTTP can always fail.
Yeah.
But we personally didn't wrap database calls into our response. So what about you? Do you trust database connection or not?
Whenever there is network in something, I cannot trust the connection. So in database calls, what can differ from person to person or project to project is maybe where exactly you want to check for the errors. And for me, I try to catch and wrap the errors of database calls as close as possible to the actual querying part, where I actually talk to database, so that I can short circuit some of the stuff, because methods tend to call each other and there are layers. I talk to my database in the repository layer, and when something fails there, I don't need to carry on with the rest of the service business logic calls.
Yeah, I understand.
It really just it's really just chaining things. And as I said, one rule of thumb I try to apply is I want to trust the types of things. And if something says it returns a maybe that it can fail, I want to trust it. I want to be able to trust it. And in cases where I don't have the possibility of an error, exceptions can always happen. That's why they are called exceptions. But for errors, I don't wrap everything. I found the validator example here. Let me quickly share my screen so I can show it here.
Sure.
Can you see my screen now?
Yes.
Let's zoom in a bit. This is from the examples page in one of the use cases. the validating user input part. This is a Kotlin example, but maybe and E types are almost same in Scala, Kotlin, or Java implementations of E. So I have a data class, which is like case class in Scala,
Yeah.
a
No.
simple class, and a validator. Here is the business, the code I am interested in. I want to print a user if it is valid, and these are the expected outputs. This print if valid takes a user, calls the user validator validate, and folds the result because user validator validate returns a maybe. In validation cases, I'm not interested in uh, producing an actual value, but I am interested in producing errors. So I'm not interested in the value part, but I am interested in dealing with the error part. So maybe of units is appropriate here. And what this does is it tries the validators one by one, and it returns in the first error. I used and then combinator of E. This is like flat map, but it doesn't take a function from you. It just expects another maybe type. It ignores the value. So basically, when there is an error, it simply returns with that maybe. And these are when expressions in Kotlin building very simple E instances. This is a dummy example, but you can see how things can work. This is a valid example.
Yeah, this looks very cool. And as I say, you didn't pass maybe as an input parameter for method. You combined few maybes using and then method. I mean, it's not. Yeah.
Yeah, but
So yes, this is correct way for me. From
yeah,
my
in the case you actually want to do that, you might want to write your validator as returning maybe of user, so that you can also use the output of a validation in following computations, and that's when you might take a maybe as an input. Maybe the validators can take another, the previous step maybe as an input. So
I really think that what you have already done is better way.
yeah, I preferred this and I wrote this, but I mean, you
Hmm?
can do the other type as well. Okay. Um, there was one last thing, I think. No, that's it on the Slack side.
Another way. We have into our response a field that calls success, like Boolean field, success, true or false. Why do we need it? I think mostly like we can just check data, and if data is null or empty or something, like then decide that it's success false and we look for error. But we also have situations whenever empty data is also success response. It's like whenever maybe wrap empty data or error. Do you use it for such cases or not?
I'm not sure if I understood the question. Do you mean why do we need something like maybe when we can return nulls or empty
No,
data?
no. Okay, my question is, do you have field, Boolean field to represent it was success maybe or failed? Like it's that we need
Ah,
to look for data or for error.
uh, okay, now I understand. The implementation is a bit different for Java, Scala, and Kotlin, but the basic idea is the maybe type behaves like the either type in Scala. Uh, Actually, the implementation is a wrapper around either in Scala, but in Kotlin and Java versions, I actually have two fields two optional fields inside, one to hold the error, one to hold the value, and all the methods and implementations are based on whether one of them exists. Not both of them can exist at the same time. So, I mean, instead of a Boolean, I have two optional values.
Yes, but I want to point out that whenever data is empty and error is empty, it's also like could be valid answer for the method. It's like we did some logic, we haven't any answer, but we also haven't any errors. So it's like success result of method successful, but data is also empty.
Instead of causing a confusion like that, I relied on the fact that if there is no failure, if there's no error, but you also don't have a data to produce, you would use the type unit or void to represent that. I relied on that fact, and in the validator example, I actually used that info.
Okay. So of course, I understand. I see.
Some similar approach is taken in Zio as well to define limits to things and to define.
And what about serialization, like transforming it to JSON? If both data is empty, error is empty.
Yeah.
I mean, whenever you transfer it to JSON, can you successfully deserialize it back?
It would depend on the encoders and decoders. I think the implementation I wrote for cases where the value type is unit to express nothing is there. It deserializes it serializes it to an empty object, and the decoder would need to check that. I don't know. Decoding is always the more tricky part. That's why I provide some basic implementations for encoders and decoders of E, but for decoding maybe type or also encoding a maybe type, you would need to provide your own implementations.
Okay, I see.
It's really up to you at that point to decide how to, encode or decode values not existing there. You could turn it into a null. You could turn it to empty object, empty array, whatever. It doesn't even have to be JSON,
Yes, I understand.
Have a good day.
Bye.
Bye.